In this problem, we want to find the magnitude of the resultant of these two forces. So what we do is we write each force in Cartesian form, add up the x, y, and z components, just like we do in every problem. Okay. The difference is this time we set it up using those position vectors. Okay. And what we do is we find them for each force. We take the magnitude of the force times the unit vector of that force. So for B, it's going from A to B. So it takes the magnitude, that's 600 pounds, times the unit vector, which has a magnitude of 1, in the direction of AB. How we find that is using position vectors. Okay, so to find the unit vector, I take the position vector from A to B and divide it by the magnitude of that position vector. So if I take a vector by its magnitude, what I'm left with is a unit vector. Because if I take a number divided by itself, I'm left with 1. So if I take a vector divided by its magnitude, I'm left with 1 with just the vector directions, which is what I'm looking for. Then I take that unit vector times the force magnitude to get that force in Cartesian form. So what I do here is I'm going to take that 600 pounds and I'm going to multiply it by the unit vector from A to B. So going from A to B, I move 3 feet in the x direction. To go from A to B, I go negative 3 feet in the y direction. And then going from A to B, going down, that would be, I go from 4 down to 2.5. So I go down 1.5 feet in the k direction. And what I do is I take that times the square root of 3 squared plus 3 squared plus 1.5 squared. That's the magnitude of that position vector from A to B. So if I took a tape measure, went from A to B, that's that straight line distance. That's what the magnitude is. The 3 minus 1.5 is the x, y, and z direction from A to B. So I go 3 in the x, negative 3 in the y, and negative 1.5 in the z to go from A to B. From this, I can take the 3 times the what I'll actually get is that denominator is going to be 4.5. Okay, you'll trust me on that. So what I do is I take the 600 times the x component divided by the magnitude. That's my I component. And then I take that 600 times the j component, negative 3, divided by the 4.5. And then I take the 600 times the z component, which is negative 1.5, divided by 4.5, in the k direction. So what I wind up getting is 400i minus 400j minus 200k. So that is that 600 pounds written in Cartesian form. It goes 400 in the x, negative 400 in the y, and negative 200 in the k. And I get that by taking that force magnitude times the position vector over the magnitude of the position vector to get that force times the unit vector to get the direction of that force along that cable from A to B. So we'll do the same thing with FC here, which is 750. And again, I'm going to take that times the how much going from A to C this time in the X, Y, and Z. So going from A to C, I go from 0 to 2 in the X. In the Y direction, I go 0 to 4, so that's plus 4. And in the Z direction, I start at 4, go back down to 0, so that's negative 4. Okay? Take that times 2 squared plus 4 squared plus 4 squared, that magnitude. This, you'll have to trust me, goes to 6. So what I basically get is I get 750 times 2/6, which is 1/3 if you want, plus 4/6 in the J minus 4/6 in the K, right? So that 2/6, 4/6, that's essentially my unit vector. Take that times 750. So it's 750 by 1/3, 750 by 2/3, 750 by negative 2/3, which gives me, that would be 250I plus 500J minus 500K. So now I've got those two forces written in Cartesian form. Now I can just add them together to find my resultant force, right? So I just add up the x's, the y's, and the z's, and I get 650 in the I, 400 plus 250. Then I get negative 400 plus 500, so that's going to be plus 100 in the j, and then I have negative 200, negative 500 gives me negative 700 in the k. I can find the magnitude of the resultant, which is all I'm looking for here. Don't have to do those coordinate direction angles, thankfully. So doing square root of the sum of the squares, I get a resultant force of 960 pounds. So again, same idea, write each force in Cartesian form, this time by taking that magnitude of the force times the position vector over its magnitude for each force to get each force in Cartesian form. And then just like before, add up the x's, y's, and z's to figure out the resultant force.